Let's see how that does. Should be all right. Stay. All right, so let's, what kind of, when I say statistic, what do you guys think? Very often you think of that phrase, don't become a statistic, like drink and drive and all that kind of stuff, right? So statistic, have there been any statistics in the news recently? Any way that you get news? Did you guys get news somehow? Do you guys keep up with stuff at all? Do you guys know who the president is right now? Do you guys realize? Okay, all right, sorry. I try not to bring politics in, but sometimes it's hard. Thankfully, nobody's wearing a red hat. So, a statistic specifically is some kind of numerical description of a group, right? So normally I think of a statistic being 68% of gross monthly students have taken a drink in the last week or something, right? To help them get through the class. You guys with me? So that would be an example of a statistic. Can somebody come up with now a statistic specifically? So it's a numerical description of a group of people or things that we have analyzed. Right? Whatever the book says. I'm kind of giving this definition a little out of order this time just because it's the way it happened. Now, what I love about the word statistic, it starts with the letter S. If I wanted to say something, now you're all like, great, Jeff, is that your letter of the day? Give me a minute. If I wanted to say something about all Grossmont students, is there something you're curious how you compare to all Grossmont students, like how far away they live on average or something? Anything you want to say about or find out about all Grossmont students? Like their average height or something silly. Anybody have any, you're like, I don't care about any of these people. Just make sure there's a spot for me to park. Yes?
Demographic.
What about? Be more specific.
Certain percentage of Latinos.
Oh, okay. So what percentage of Grossmont students are Latino? I love it. So this is the parameter is the numerical description of all people or things that we want to describe. All right, so this is the same thing as a statistic, but it talks about all people or things. Now there's I've never kind of described it like this before, but there's a distinction between the two. They both would sound the same. A parameter would be 37% of Grossmont students are Latino. I have zero idea if that's true. We can go to the scorecard on the thing and see the demographics. That would be a parameter. If I said 37% of the group of students I selected are Latino, that would be a statistic. So a statistic describes the subgroup that you work with, that you actually looked at. A parameter describes everybody that you want to say something about. So if we wanted to say something about all Grossmont students, do we have the resources to look at every Grossmont student?
No.
Do we? No. Because believe it or not, some of them never come to college. They never come to campus. They're online. So we would have to do something, and plus there's just too many. Right? Do you have any idea how many Grossmont students there are? A lot, like 19,000 something. Right? Do you have time to go talk to 19,000 people?
Yeah, next Tuesday.
No. So then what do we do normally in statistics? We take a sample. See, that's what I mean. Statistic describes a sample. S. Where do we take a statistic, a sample from? We take a sample from the entire population. Parameter, population, statistic, sample. That should happen more often in math, too. It does. So a statistic describes a sample. Oh my gosh, you're brand new. pen. That's awesome. And a parameter describes a population. Statistic describes a sample. Parameter describes a population. Holy shit. They don't like that stuff. So if I said 74% of all airline pilots took a drink an hour before it was taken off, would that be a statistic or a parameter? There's a magic word in there. It's the word all. So that's a parameter describing all of them. If I said 32% of airline passengers are unaware that their pilot took a drink, that's a little bit more hidden, but I didn't make it specific. It must be a parameter. If I said 32% of the 118 passengers I spoke to, that would be a statistic. I guess so. A statistic describes a subgroup, a sample. Parameter describes everybody. So very often, what do we do in stats? We take a sample, we figure something out from them, and then we say it about everybody. If you pay anybody in here pay any attention to like the elections, you know elections coming up? Have you registered to vote? Even if you don't give a shit, you do. You should. Right? So please do God. I'm not even going to ask you which way to vote. Just everybody should vote. And then we have a more representative government. It's crazy. Anybody pay any attention to polls and stuff like that? Like 44% of the people are going to vote for, who's the people for government? Newsom and Cox, right? You guys, anybody pay attention? 44% of the people are going to vote for candidate A, and 42% of people are going to vote for candidate B. It sounds like it's over then. It's like, why would I even vote? They already know that A won. But what do they always say at the bottom of the screen or something? Anybody ever pay attention?
Right.
Plus or minus 4 points. All right. So the 44% is a parameter. It's describing the whole population of California voters. But the bottom is really saying that was actually a subgroup we got that from. Plus or minus 4% kind of covers our ass. Later this semester, we're going to actually calculate that plus or minus 4. It's not just to go, we don't know. Let's say plus or minus 5. No, it actually is calculated from how big the sample was and some other factors that we don't even know yet. But we'll be able to calculate that later. How are you guys doing so far? Okay. Okay. Let's see. So this so far, just to make sure, you know, I should probably reference the book so I can tell you where we are. 7 in section 1.
Page 7.
1. I'm not saying hit page numbers because some of you might have it on their phone. Yeah, I like it. Blah, 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 blah. Okay, all right. So let's do this. Let me come back to the specific thing we're talking about, the percentage Latino. Percentage that corresponds to the word Latino. So what would our population be in that case? If we wanted a percentage of correspondence students who are Latino, what's our population? Correspondence students, 11. And then give me an example of a sample we could take.
In math class.
Math
In math
department?
Okay, I like it. Okay. I like the way you're thinking. So let me come at you like this. You guys are a decent size sample. Everybody in here is a gross fund student.
Compared to 90,000?
Yes, believe it or not, yes. Yes. The required sample size. Now Gallup, anybody ever heard of Gallup? Gallup is one of my go-to sites for quick statistics stuff. Yep. I would say this to me. Sorry. Okay. So Gallup, when they do, where's the news on here? News. This is so silly. This used to be their front page here. Someday. All right. So whenever they do a poll, so see here, look at Trump approval numbers. If you're a Trump fan, I'm really sorry. I'm not trying to put this in your face, but just saying. Notice here they say plus or minus 3 percentage points, for example, right? But they also tell you at the bottom of a more specific one, I think it's a little too general. Like here, let's do this. Let's look at education, higher education, since that's where we are. College students see less secure First Amendment rights. That's interesting. If you go to the very bottom, they tell you survey methods. So they tell you how many students they spoke to. That's actually a lot. They normally do like 1,000 Americans to represent all of America. Right? And how many Americans are there at the moment? They may know roughly. I think it's 320 or 330 million. I remember when we passed 300 million. Right? You keep making more people, that's more people that make more people. So they do like 1,000 or 1,200 or something people to represent 320 million. Now in your brain you're thinking, well that's shit. But the way statistics works, it's actually enough people. Now that's if you pick a good sample. Now you guys, let me come back to you guys. Are you guys a good sample for me to use to start to analyze this question?
No.
Why are you not? You're not bad people, as far as I know.
We're going to get a list of them.
No, but what if the police have Latinos here in this class, right?
Okay, but why would that be different from the general probability of
Because
having
it's just one class out of...
Beautiful. All right, so let's think about why you guys are not a good sample. What time is it?
It's early in the morning, not too
Is there a chance that, and also what kind of class is this? It's a math class. It's a transfer level math class. Are any of those, maybe there's more or less Latinos who take early courses. Maybe there's more or less Latinos that take this course, right? But coming at it from the other side, something that I think you're getting at, it's on campus, so we don't have any online representation. It's all about representation. Do I have a good representation of all of Grossmont if I use this class? No. Does everybody have to take Math 160? No. Is everybody able to take a 7 a.m. course? No. Right? Is everybody on ground? I love that. You know that there's online, and the other way they call it is on ground? In my head, I'm always thinking, we're like this. I love that on ground. Do you guys understand what's happening? So what does it mean to be a good sample then? How would I take? Why are you guys not a good sample? You guys are what's called a convenient sample. You're a convenience. It's convenient for me. How much work did I do to put the sample together? None. Did I do any attempt to make it representative? No. So it's convenient sample. Almost always there will be some kind of a bias. Right? Maybe more white people take early morning classes. So therefore the percentage of Latino will be smaller than it really should be. Right? You guys understand what's happening? I have no idea how the demographics affect early or late classes, but who knows? You don't know. How can I start to make it more representative? How would I try to select a sample from Grossmont students that's more representative? What could you do? So, no? Okay, I love it. So go across a bunch of classes, right? How would you pick those classes?
Just get the list of all the students.
Beautiful. Okay, so one way to do it is to get a list of all the students, and then you can like throw darts at it. Randomly select students, right? You can just paste it on the back wall and you start throwing darts at it, right? And then whoever you hit, that's the student you pick. Are you guys with me? So what's the underlying idea? Why would you want to go to multiple classes? Why would you want to do a list of all the students? Okay, a lot of people don't understand what random means, right? Especially watching YouTube. I'm so random. Just shut up. Yes. Yes, so I'm always trying to represent the population better, which means, here comes a definition. So to be a truly random sample, everything or person in the population has to have a chance to be in the sample. So if I choose you as my sample, did I give everything in the population a chance? No, because not everybody has to take this course. Not everybody can take a 7 a.m. course, and so forth. So, random sample is the ultimate goal of any sampling that we do, and to be representative because everything in the population has a chance to be in the sample? So really, to try to achieve the goal of representing the population, everything in the population has to have a chance to be in the sample. Cool, and then that would be representative. Because if everybody has a chance to be in the sample, then as you pick them, as long as you pick them randomly, don't just pick all the people you know, because then not everybody has a chance, because you don't know everybody. So if you try to give everybody a chance to be in the sample, then your sample will have a good chance of being representative. And that's why 1,200 people is a big enough population. If you choose them randomly, then that 1,200 should actually represent your population pretty well. That's why they can call elections before they've counted every vote. Because they know that what they've gotten so far is a good representation of everybody. Of course, if you were alive back in 2000, and Chaz and Florida and shit. Anyway. All right, how you guys feeling so far? So we've got population, parameter describes it. We got a sample, a statistics describes that. How do you pick a sample? It's another little subgroup, and I wanted to define random sample right now. That's always our goal, is to have a random sample. I like it. Oh, I have one over here. Look at that. I think that was from 1970. Okay, so let's get into, let's do this. I'm going to do things a little out of order. I think this is in section 1.3, and I don't care. Here's the types of samples. Let's talk about types of samples. And then we'll come back and talk about different variables. I think this is section 1.3. I won't check it out. Could be true. It's in chapter 1 somewhere. So we have the random sample, which is really the goal always, and we already talked about that. Then we have something called systematic. Automatic, systematic. So let me trip you up a little bit. If I say you are my population, are you guys cool with that? As a teacher of this class, that makes sense. This isn't, you are my population. And I want to take a sample of students from this population. If I randomly pick rows and take everybody in those rows, would that be random? So if I randomly choose rows, this row and that row and that row, and I take everybody in that row, is that random?
No.
Why not?
It has to be
No,
every
no.
row segmented us and then you check.
Before I picked any rows, can you point to a group of people or even one person that doesn't have a chance to be in the sample? Tell me. Before I pick any rows, who does not have a chance to be in the sample? Because my population is the students who are here right now. Does anybody not have a chance?
No.
No. Everybody has a chance. Therefore, it is random. Very often we think about after I've chosen rows, you're like, well, then that row didn't have a chance. Yes, they did. Before I picked, they had a chance. So you can't look at after I picked. Well, you didn't pick Fred. I don't have to pick everybody, or else the whole idea goes out the door. Right? All right, so systematic, though, would be this. Systematic would be randomly choose a person and then take every fourth person after that. Why is that random? Why is that a random type of sample? Does everybody have a chance? Yes, because I randomly select where I start, and then I take every fourth person. So depending on that first person, everybody has a chance. So that's systematic. It's every fourth person. Every 10th minute, I take the temperature. Every third wheel, I take off the assembly line and I check it. Every nth something. That's systematic. Every nth item, take it. I like it.
I was so confused on that. I really liked that.
Does it make sense now?
Kind of, yeah.
Kind of? That's not good enough. So, like I said, if I went outside and took the temperature every 5 minutes and plotted it, you can kind of expect how it's going to go, right? So that's a decent way to gauge how the temperature is changing. Every 5 minutes, I go take the temperature, right? Every 10 minutes, I see how many cars are on the road, just to get a gauge for what the traffic is. Or every fifth person that goes by me at the mall, I ask them their opinion or something. And that's sort of convenience, but still, that's sort of a systematic. There's a every something. Every 12 feet, I take some grass, and then I take it back to analyze it to see if some chemical is affected. You guys, every nth something. So systematic is really kind of easy to tell. I don't want to set a drop box. Okay, that's systematic. So I really want you to be careful. Our ultimate goal, no matter how we take a sample, is for it to be random. But the answer to every question is not to be random. You have to be more specific. If I do every 8th turtle that I see, I take them to check them out. That's systematic. It's also random. Because any turtle had a chance to be in the sample. You guys with me? No matter which way I went or which turtle I picked first, and every 8th one after that I see I pick. You guys understand? So everybody had a chance, but it's more specific than just saying random. It's systematic. Maybe. So just say random for everything.
So is there a process of random sampling besides?
So for something to just be random means I haven't put any system in place. That would be like putting everybody's name in a hat and picking them out. That's purely random. There's no system to it that would be a more complicated thing. Systematic, there's a system to it. You gotta love that. There's a process I use to do it. So it's not just random, it's systematic. I like it. The next two I sort of like to do together because they're very similar. There is stratified and there's cluster. Hopefully it sounds familiar. Maybe you've read ahead. They both have the same first step. Break your population into groups. Doesn't have to be 3 groups, but I just want to draw 3 things. So say there's 3 classrooms with people in it right now on campus. So that would be naturally broken. Or I can break it up into zip codes. Or I can break it up in high school, freshmen, sophomores, juniors, seniors, right? You guys with me? So one reason why you want to use one of these 2 methods is if you're going to say something about how students feel about some rule, you want to make sure that you represent all the different groups, right? You don't want to have some published result and say, we didn't talk to any freshmen, but the freshmen are going to be like, what the hell? Right, I'm going to shut up. All right. So say there's 3 classrooms. Stratified is sort of like what I was talking about. Well, no, I think I was doing cluster earlier. Stratified would be from each of these, from each, take some. That's stratified. So from each room, each classroom, I would take some students to be in my sample. All right, red. Get easier. You guys with me? Stratified. Some from all. Some from all. Strata is going across the strata. I don't know how to further just don't find this. Cluster would say, take a few, take all from some. So randomly select a couple and then take everybody. Students very often think this is not random. It's like, they didn't have it. Yes, they did have a chance. I could have randomly selected that classroom. That's just like the row thing I did earlier. So they both have the same first step. It could be break up into zip codes. Stratify would be take some people from every zip code. Cluster would be take everybody from certain zip codes. I like it. How are we doing? You guys see the difference? Those kind of suck because they do start off the same way. Stratified is some from all. Cluster is the other one. Cluster is all from some. Sounds vaguely Three Musketeers. All from some and some from all. And then the 5th thing up here is the sucky thing, the thing we already talked about, convenience. Convenience is bad. Convenience lends itself to bias in your sample. So if I just talk to people I know about how they feel about math, I think I'm going to get skewed results. a lot of people I know rely on math, right? You with me? I don't, you're like, yeah, you only talk. No, thank God I don't do that. But it would certainly be skewed. The results of my survey would be skewed. Any poll that a specific news channel does nowadays is automatically skewed, because who's going to answer that poll? People watching that news show. It didn't always used to be like this, but now, you tell me what news show you watch, I know how you vote, right? I mean, it's just bullshit. But, oh well, that's the way it is. I used to joke that you'd ask your barber what political party they were before they cut your hair. We're almost to that point now, right? You're a what? Don't touch my hair. All right, how are we feeling about these? These are different ways to select samples. These 1 through 4 are valid methods to get a random sample. The fifth one sucks. You like it, maybe. There was somebody who was in the military told me that cluster sucked, and I had to get into that a little bit further. This is back when I taught intersection statistics. Actually, it's a while back. But what they did was, everybody knows there was a war in Iraq. It still is. Anyway, after they took Iraq, they went into Iraq. They wanted to investigate the neighborhoods after they thought they settled things down. They wanted to see how bad the neighborhoods were doing. So they sent in some researchers to get some samples and figure out data. So they did a cluster approach. They clustered it into regions. Now, unfortunately, what they did was, well, we're not going to go to this region because we know it's not safe. So we're just going to go to the safe regions. So it wasn't quite that bad, but that was in there. You understand what I'm saying? That was part of their reason. Therefore, it was not random, was it? In fact, they were completely biasing it in the incorrect direction. There was some controversy about whether they were directed to do that, to make things seem rosier than they were, but oh well. So this is why the person didn't buy into cluster sampling, but I tried to explain to him, he kind of understood. They just misapplied it. They didn't do it correctly. So of course it's going to lead to bullshit. No problem with cluster if you do it correctly. You have to make anything possible. You can't say, well, I'm not going to go there. Nope, you don't have a random sample, stop. I can't trust anything you do. Okay. Any questions about these?
Yeah, what's your last step?
No attempt to make it random is made. No attempt at making it random. Now, the misunderstanding about randomness, I could totally correctly do a systematic approach and end up with a sample that's bullshit. Because randomly that could happen. I could do a convenience sample and end up with a sample that's awesome, that's completely representative, that's perfect. How do I have I don't have a clue whether that's true or not. So we have to try to put processes in place to make it random. If I don't, I have to assume it's bad. Because I don't know. There's no way to know. You guys with me? So if I did a bunch of convenience sampling, most of them would end up being non-representative. Some of them would be beautiful. And most of these would be fantastic. Some of them would be shit. So if I randomly select people in this classroom, is it possible that I pick all the shortest people? Is that possible? Is it possible? If I randomly select people, is it possible I pick the shortest people in class? Yes, of course it's possible. Is it likely? No. So if I do one of those processes that I randomly select, everybody's represented, then I can trust the average height to be representative of everybody, even though there's a chance that I just happen to pick all the smallest people. Why do I live with that? Because it's very unlikely. You guys would. One thing I love about statistics that a lot of people hate is it's the most honest math. It tells you, well, there's a chance you're wrong. Well, there's a chance that isn't right. And people don't like it because they think math is black and white and they want, tell me what it is. And like statistics goes, dude, I am the math of life. Life is uncertain, too damn bad. We make choices based on probabilities. We can never know the probability, 100%. There's no way. You guys with me? Maybe? All right. You're all like, I don't know yet. I don't know what that means for how the work is going to look. Okay, I think one more idea, then we might head out here a little early. Right, and this idea has actually got a lot of parts. Don't get too excited. No questions on this? Okay, all right, all right. So, kind of backstepping a little bit, I want to go back and talk about types of variables and types of data. Yep. All right, let's see. Let's do something. There's two main ways to break down variables. They're either qualitative I like that. I heard somebody. Quantitative. Qualitative, quantitative. Quantitative, that's the easy one to start with. Quantitative, what's the root kind of word of this? Quantity. So this is probably the one that's truly, what? Quantity. Sounds like I can count it. It's truly numerical. Truly numerical. Oh my gosh. Truly numerical. What do I mean by that? If I had a jersey number of 72, is 72 like truly numerical? Or is it just a name for me? That's a name. I loved it. One semester I had 3 girls from the basketball team. And I said, if you take your jersey number minus your jersey number, the answer doesn't mean anything. And they're like, yes, it does. It's Michelle. It's like 18, 16, and 2. It's like, shit. But to be truly numerical means I can subtract and divide and it makes sense, that kind of stuff, right? So if I take somebody's jersey number and subtract somebody else's jersey number, does the answer mean anything? 72 and 70? I'm too better than shit. No, it's just your name. So that's what I mean by truly numerical. Measurements are almost automatically quantitative, right? If I measure the temperature, if I measure how long a song lasts, if I measure how long you've been on the earth, if I measure the weight of a turtle, right? I don't know what it is about turtles today, but truly numerical, meaning like, for example, almost any measurement. Height, weight, temperature, gather. Whereas qualitative, quality, it's also called categorical data. So this hair color, right? If I subtract blonde minus brown, what the shit is the answer to that? I don't know. What's the average hair color? That doesn't even make sense. You can't add hair colors and divide. If anybody knows physics, you can take wavelengths, but screw that. Qualitative is categorical data, name data. So really, a basic way is qualitative is names of things, quantitative is numbers, measurements. So there will be some homework questions where they'll say, what is this, qualitative or quantitative? I like it. How are we doing with that? Is that decent? I mean, that's not too evil yet. I don't know yet. You have got to try out this chapter 1 homework very soon. Maybe before the next time I see you, right? Okay. So, what about types of data? So variables are related to the question that you ask. So if I wanted to know the percentage of students who are Latino, and you get a sample, what are you going to ask each student? Are you Latino? There you go. So in that case, the variable would be their ethnicity, right? Their reply is the data. So if I ask it as, are you Latino, then the reply would be yes or no, right? Or you could say, what's your ethnicity, and then the reply would be Latino, Caucasian, whatever, right? I like it. I remember I used to work at a hospital, and we put race down as a new thing, and I put human a couple times. And Dr. Mysteries uses Indian doctor. Jeff, I don't treat dogs or cats. I know they're human. I was like, all right, I'm sorry. I love Dr. Mysteries. So there's, not too bad, not too bad. Here there's 4 main types of data. Let me just put them all up here, we'll talk about them. 2 of them are related to qualitative. 2 of them are related to quantitative. No, not that, not discrete yet. This is nominal, ordinal. Those are related to qualitative, interval, ratio. Those are related to quantitative data. Now, believe it or not, the words we use are important. You have to go in knowing what these words mean because I have to be able to categorize something before I know how to analyze it. There are certain things I could do with qualitative data that I can't do with quantitative and vice versa. So I have to have some way in my brain of knowing what something is. So there's a reason we do this terminology stuff. Nominal. Anybody like to read books anymore? Yes. Do you know what the phrase plume de nom means? Yeah, sort of like Stephen King. He wrote books under the name Richard Bachman. So plume de nom is a pen name. If you like Stephen King, look up Richard Bachman. That's King in his like early day prime. Holy shit, right? If you don't like Stephen King, then look up something else. So nominal, nom. For some reason, people see that and they think number. It's not num, it's nom, right? It's name data. It's just names. So, like, if I ask you what your name is, that would be a list of names as nominal data. If I said, what color hair do you have, right? Not what color does it look like, what color hair do you have? Then you tell me what color hair you have, right? Green, blonde, bald, whatever. Ordinal adds something to this. Every step adds it. So ordinal is names, but it's names that have an inherent what? Order. Gotta love that shit. So if I take your names, is there an inherent order? If I say Julie, Adam, Mark, is there a problem with what I've said? No. There's no inherent. Can I put them in alphabetical order? Yes. First name or last name. Either way, it's up to you. It's not required to be in order. Now, if I said rate my performance so far, has my performance been good, poor, excellent, fair? Have I given that to you in order? No. It's kind of like, are you trying to trick us? What the shit? Like, have you ever done faculty evaluations here? We have 1 through 6 or something. If they put on the top of there, agree, strongly disagree, neutral, agree, it's like, what? Are you trying to trick me? So very often, ordinal data is like rankings. They're in order. You wouldn't say, and now the winner and the 7th runner-up and the 2nd runner-up and the what the shit? No. You do 7th and 6th, 7th runner-up. Holy shit. So ordinal has inherent order. Like, so it's a name. If I said I was a 2nd place person in the race, that's like my name, but it's also the order I came in. So 2nd place, there's an order to it. If I said that's a 4-star restaurant, that's a name for the restaurant, but it's also an inherent order to it. 4-star, then 3-star, then 2-star, right? Maybe. Where would political party go? Which one? It's definitely not quantitative.
No.
It's purely nominal, right? I don't care how you feel, right? My party comes first. Not necessarily. It doesn't matter. There's no order. There's no inherent order to them. Where would a Social Security number go? Now this is.
Why wouldn't that be nominal?
I would say so. It's nominal, but do you guys know like the first 3 of mine is 258? I'm not going to give you the. And I didn't know this until much later in life that meant that I was born in Georgia. Right? 258 is a Georgia Social Security number. So the first 3 of your social should identify what region you were born in. It's really interesting. You guys with me? But they do give it to you in order within that. So, let me make sure you guys understand. In the homework and on the test or quizzes, depending on the way you argue something, I could actually take a couple different answers. So if I said, the slip of paper you get when you go to the DMV, the thing that's on there, which one would that be? I would take ordinal is the one that makes the most sense, but they can argue that there's multiple. There's B and G and H and whatever the hell, right? I haven't been there in a while, to be honest. Is it still cool?
Yeah.
Yeah. And you're like, B47, you're B48, and then 5 hours later, G40, H, I want B. All right, sorry. That was my experience last time I was there. So I would take ordinal, but you can actually argue nominal. It's just the name, because it really isn't fully in order. You can actually sort of argue interval. No, these two are numerical. I want to make sure I let you out early, like I said. Interval is the one where subtraction makes sense. What do I mean by that? Can you subtract 2 zip codes and get an answer? Can you? Can you? My zip code is 91941. What's your zip code?
91942.
Oh my God. So if you subtract them, you get 1. Right? Don't you? Do you not? Does that 1 mean shit? It doesn't mean shit, right? You guys with me? It's in Lamesa, I know, but does that 1 mean something? Huh? You're 1 better than me. Whatever. You guys understand what I'm saying? So the answer doesn't mean something. So just because something, like if I subtract 2 jersey numbers, do you get a number? Yes. Does it mean something?
No.
So that's what I mean by subtraction makes sense. What year were you born?
96.
And I was born in 72. Oh my God. So if you subtract those, does the answer mean something? Does it make sense? Yes, it means the age difference, right? Cool. All right, all right. So interval is numerical data where subtraction makes sense. Ratio, not only does subtraction make sense, but so does, now what's ratio mean? What's the mathematical idea of ratio? What's a ratio of numbers? Yes, it's division. It's a fraction. It's division. So ratio is the one where division makes sense. If I divided 1996 by 1972, do you get an answer? If you put it in your calculator, do you get an answer? Yes. Does it mean anything? No. It doesn't mean shit. Right? So that's why year of birth would be interval, not ratio. Well, what about age? What about age? So if somebody in here is 20 and somebody else is 40, what's 40 divided by 20? Does that number mean something? The 40-year-old is twice as old as the 20-year-old. Yes. Now, mathematically, here's why. Year of birth. What does 0 mean? Does it mean absence of things? No. 0 in our time scale actually means nothing. Depends on your religion, right? 0 doesn't mean their creation. There were things before 0, of course. You with me? Back then, they didn't call it 88 BC or something. They didn't have that. Oh, it's 88 before? No, they didn't know shit. But you guys with me? 0 doesn't mean what it's supposed to mean. So ratio is where division makes sense. Why would division make sense? Because 0 is where it's supposed to be. Division makes sense, and 0 means what it should. So what about age? So year of birth is interval, because I can subtract them and it makes sense, but division doesn't. And also, the years don't have 0 in the right place. What about age? What does 0 mean as far as age? It means you don't exist yet. You haven't come into the world, right? I'm not going to get into any really interesting murky water about. I'm just saying you have not presented the world yourself yet, right? So you're not on the earth yet. You with me? Yourself. So at 0 means what it's supposed to mean. There's no time to count yet. You haven't existed out in the world yet. That's why age is ratio. Since 0 is where it's supposed to be, division makes sense. What about temperature? How many temperature scales do you guys know? Most of us know 2. Some of us might know 3. There's Celsius, Fahrenheit. Kelvin is the one. 0 means absence of all energy. 0, that's the absolute 0. If you get to 0 Kelvin, we're all dead. There's no energy anywhere. You don't want to do that. I was doing research at Old Dominion in my grad school where I was taking rubidium atoms and cooling them almost to absolute 0. And then they kind of overlap and make this giant atom. We try and make a maser, which is a matter of laser. Enough of that stuff. So there are applications of stuff near 0. That's the thing where you see magnets floating and this superconductivity nowadays. But Celsius and Fahrenheit, what does 0 Fahrenheit mean? What is 0 Celsius? Can you not get colder than those? Does it mean the absence of heat? The 0 Celsius, no, you can get colder than that. Of course you can, right? If you live up in Minneapolis or something, you know. Well, San Diego, we don't know that things go below like 4. But 0 on Celsius and Fahrenheit does not mean what it's supposed to mean. So Fahrenheit and Celsius temperature, where would that go? Interval. You can subtract them. I can say it's 10 degrees hotter today than it was yesterday, but I can't say it's 5 times as hot and have the numbers match up. What's 5 times as hot as 0? Not 0. That doesn't make any damn sense. You see, when 0 is in the wrong place, it doesn't allow division to make sense. Hopefully this. Some of you guys might see what I mean. Yes?
So like Fahrenheit is the interval and Kelvin's ratio?
Kelvin would be ratio. Kelvin would be ratio because 0 is where it's supposed to be. If you don't know Kelvin, you don't suddenly have to know Kelvin. Please to God. I'm not going to ask you a damn thing about Kelvin. If you're curious, you can Google it. You see Lord Kelvin up there, right? It's like, I got a thing named after me, but nobody knows about it. Bullshit. Maybe. So we have, let me think. There is some ideas I still have to do in chapter 1, but we actually have covered most of it, to be honest. So on Wednesday, we're going to finish up chapter 1. I'm going to send an email out to you guys to remind you about the survey to fill out. If any of you need to see me, I think at least one person needs an ad code, or if you have something else to see me about, come on up. Otherwise, I'll see you on Wednesday. Especially because we have a 7 a.m. start time. I don't want you to miss the lecture. So if it becomes an issue, I can either let you take the quiz or later that day.
Okay.
But we'll just have to. Okay. But you have to set up your ARC? Oh. I want to go.
I just need an extra. I'm going to get one right now.
Who's going to use this? Did I get you? There you go. Oh, it's on the website. Right there. Go to the website, Math 160, and the first couple are to the surveys.
I'll look at it once I get the book. Once I get able to be registered. I have to go to ARC.
Depends on what you have to do after this. That's the latest stuff.
Don't you have to go to the office?
Yeah.
Once you're out,
I was just going to
we're-
call, but
you would
I might as well just go
If
in.
you had enough money
I don't know
on
what
computer labs, we'd probably do statistics for yourself.
Because I just.
So this is a mobile answer to that.
Yeah, I got that.
So just rent it, and then whatever job you go into, Excel is one of the do things. Yeah. Oh, you can get a hard copy if you want to, but like I said, you can download the PDF. You can print out just the homework sections and just kind of read through the stuff. Or you can order a hard copy, either way. I don't think some people like to have the hard copy book, and it's only like $33.50 through Amazon, so. They might have some in the bookstore, too. I can't remember if they ordered them or not, but you can check it out. Yeah, but they always jack the prices anyway, so, yeah.
Is this calculator okay?
Yeah, totally.
Okay.
Mhm. Okay. Oh, either way. Is it soon or is it going to be like a test day or something?
I saw that everything was in 12.
Okay.
So it's
So the closer we get to this, remind me.
it's becoming
Okay, so, I see. Okay. Yeah, so that's going to be, so you have to kind of keep up. Thankfully, you do the YouTube thing. Which reminds me, I might as well cut the camera off there. This is not exciting stuff.